Hey guys, welcome back to the course. In this lecture, we are going to understand how runtime errors can be better managed in Python. The purpose of exception handling is to anticipate and gracefully manage runtime errors or exceptional situations that may occur during the execution of a program. It provides a way to intercept and manage unforeseen situations, preventing them from causing the entire program to come to a halt. At its core, exception handling uses try and except blocks. The try block has the code that might raise an exception. In other words, this is where the main logic of the code is written. For example, if the code is supposed to add two numbers, then that code will lie under the try block. The except block specifies the actions that are supposed to be taken if an exception occurs during the execution of the code written under the try block. For example, if our code fails to add two numbers, then that event will be captured under the exception block. This allows us to maintain the program flow even in the case of unexpected errors. Now let's review this with a practical example. It's a very simple example where we are just adding two numbers and printing the final value on the console. Let's run it and see what we get. As expected, we got the value 5. So far, so good. Now let's change this a little bit and make variable b store a string value instead of an integer value. With this, the print statement is now going to try adding an integer value from variable a with a string value from variable b. This is going to fail because technically we cannot add a number with a string. Let's run it and see what happens. As expected, it failed with this error. Now, this was a very small example in a controlled setting. Imagine running 1,000-line code with multiple calls to different functions, methods, etc. A small mistake there can prove to be devastating and result in a poor user experience. In fact, I'm very sure that almost all of us have seen such examples in real world where you try to go to a web page and you get a very long, ugly error message with strange looking hexadecimal codes and jargon. One of the reasons why that can happen is if the developers have not made proper exception handling arrangements in their code. Now let's add the exception handling component here. You see we have two blocks called try and except. As I explained earlier, the try block is where you will write the logic and except is where you will cache the exception. Let's try to add the value of variables a and b in the try block, and in the except block, we are going to print a simple message that says an error has occurred. Let's run the program again and see what we get. As you can see, the code has still failed, but we now have a user-friendly message in plain English instead of all that jargon we saw earlier. This is extremely useful from a user experience point of view. Another important thing to note is that just because we are presenting a message to the end users, it does not mean that we should not investigate the reason behind the code failure. The ideal situation would be to capture the failure details in some sort of a database for further troubleshooting behind the scenes while simultaneously presenting the user-friendly message so that end user experience is not affected. I hope you found this demonstration helpful in understanding why reliable exception handling procedures are critical in a production code. So with that, I thank you for joining me this journey and I hope you find the rest of the course useful as well.